Hi everyone, my name is Nelson. Guys, I'm going to take you through the concept of number system. Remember, number system is a big name, and under it we have real numbers. Now let's have this journey together. Okay, number system, we have what you call real numbers, and under real numbers it branches into two concepts as well. Real numbers, we know that if a number is real, it's either rational or irrational. But under rationals, we have the following under rationals, guys. So a rational number can be expressed as A over B. Anything that you can express as over B, you know that is rational. But remember, look at this. B is not equal to 0. Your mathematicians, guys, you know that if B is 0, therefore the whole fraction is going to be undefined. Cool. Now, the second aspect is irrationals. So you must know what irrational numbers are. Okay, now I'm going to take you through rational numbers, just to classify that, because we don't have specific set of numbers that are rationals. We have quite different numbers or categories of rational numbers. Okay, let's have a look now. We're saying rational numbers. Look at that, 2 over 3. Is 2 over 3 a fraction? The first question you ask yourself, is 2 over 3 a fraction? Yes, yes goes with yes, rational. And another type can be a mixed number. We know that we always convert our mixed numbers to improper fractions. Yes, we're going to say that is a fraction. It is rational. Another thing can be just 5, just 6, just 10, because any whole number can be expressed as 5 over 1. If that is not built as a fraction, you can build it as 5 over 1. Cool. Now, another thing that we tend to confuse with irrational. 0.5, we're saying this has a terminating decimals. The decimals are terminating there. Therefore, this is under the category of rational numbers because can go to, if you look at that, go to 5 over 10. Right, guys? Another thing, square root of 9. Listen, when you talk of square root of 9, don't just say because I've got the radical there, square root of 9, therefore this must be irrational. Work it out and see from the square root. Once you work it out or you get help from your calculator, then if it gives like decimal from square root, you know that this has to be irrational. But let's have a look when we work out the square root of 9. What do we have? Square root of 9 here is 3, if you look at that. We have 3, and then that goes to 3 over 1. Therefore, what do you know? Rational. Cool. Now, 0.6 recurring. Again, guys, we have a problem. 0.6 recurring. Some people will say 0.6666, it goes forever. Since it goes forever, it means irrational. No, 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 that is not true. 0.6 recurring can be converted to A over B. Remember, a fraction it's rational. Or any number that can be expressed as a fraction, it's called rational. Have a look how we're going to manipulate on 0.666666 and make it a fraction so that it gets the name of rational. Come along. Right, 0.6. We know that 0.6 is 0.666666, as I said. And then we're saying the method we're using here, we introduce variable x. We say let x be that number, and we're going to shift these decimals bit by bit to the left-hand side of comma. And then I have, look, if I move this comma to there, I should multiply by 10. It's an equation already. Multiply by 10 here, multiply by 10 there. Where do we go? Then 10x is equal to, I shifted 1/6. Good, look at this. The main thing is to get the same decimals. Yes, 0.6. The second equation is 0.6. Now you should be happy. Once you have this, we know that you can subtract the two. Subtract your left and subtract your right. And then where do we go? 9x is equal to 6. Therefore, x is equal to 6 over 9, then 2 over 3. That is rational. Good. We know that. That is rational, guys. Okay, let's talk of irrational numbers quickly. Irrational numbers cannot be expressed as A over B. If you look at this statement here, we say cannot be expressed as A over B. Good. For example, for instance, root 2, as I said, irrational. Okay, moving to like square root of 11. It's irrational, but this question says between which two integers does square root of 11 lie? So what do we do? Guys, square root of 11, we need 11 by itself. We need this, the perfect square before 11 and the perfect square after 11. Okay, before 11 should be 9, and immediately after 11 is 16. Have a look. We have the following. We need the integers. It's 9 and 16. So we put the roots in, but square root of 9 is 3. Then the square root of 16 is 4. Now we're saying the integer, remember the integers are not decimals, is between 3 and 4. Good. Now we have something that is undefined here, only if the denominator is 0. Let's say we give you the denominator. Your rational number is now have the denominator of 0. We're going to say this thing is undefined. Cool, guys. Right. In the next lesson, I'm going to take you through this concept of undefined. How do we apply this concept? We don't just say something is undefined and leave it there. There are some mathematical concepts related to this. So I'm going to take you through this journey. See you in the next segment.